Okay, so we're going to talk about chemical reactions. So during the chemical reactions, new substances are formed. Reactants are transformed into different products. Atoms are never created or destroyed, but they are rearranged. A chemical equation represents what happens during a reaction. The following is an example of a chemical equation right here. The equation describes the reaction of calcium with nitric acid to produce calcium nitrate and hydrogen gas. You may notice that there are more total atoms on the right side than there are on the left side of the equation. If this seems strange to you, don't worry about it. We'll fix this on a later day. Note, in the above equation, hydrogen gas is written as H2 and not simply as H. There are always a few elements that exist as diatomic molecules. If a substance is diatomic, then a substance must always be bonded to something. A hydrogen atom is diatomic, and so it must be bonded to something else, like in HCl or HNO3. If nothing is available for it to bond to, it will bond to itself by forming H2. All the diatomic elements are listed below. So here are the 7 diatomics: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So again, they don't exist by themselves. They will exist copied to themselves or bonded to themselves, okay? Now there's a made-up name. Mr. Brinkelhoff is a way to remember. I would find a way to know these because you need to know them. I'd write them on my periodic table or something to that extent. So let's talk about some questions here. So consider this equation here. Why is bromine written as B2 on the right side? Well, it's because it's diatomic, right? Why is it necessary for LiBr? Why is it not necessary for LiBr to be written as LiBr2? Because it's bonded, right? Because the Br is bonded to Li. So it's not diatomic anymore. It's now bonded. What are the reactants in the example? It's everything to the left. So the reactants are LiBr and P. So that's the information we could get from that equation. Now let's look at this equation. And we got Na plus MgCl2 makes NaCl plus Mg. Why can't NaMg be produced? Why can't Na and Mg be produced? Because if you remember with compounds, right? Ionic compounds, they are both positively charged. Okay? Remember, 2 positive charges can't make a compound. Why can't NaCl2 be produced? Because Na has a positive 1 charge and Cl has a negative 1 charge. So it's going to be in a 1-to-1 ratio when they make it. Are NaCl and Mg the only products that can be produced? You betcha. Yes. Here's another equation. You got lithium and calcium phosphate to make lithium phosphate and calcium. Why can't Ca and Li make it? Because they are both positive ions. Positive ions don't make compounds. Why can't Li3P be produced? Because if you look on this side, it's PO4 is a reactant. So you need PO4 as a product. Are Li3PO4 and Ca the only substances that be produced? And of course the answer is yes. All right, so I want you to write down these chemical equations for the following reactions. I'm going to pause it now. Please pause it yourself and do that.
Okay, so aluminum sulfate reacts with barium to produce barium sulfate and aluminum. So aluminum sulfate, we have aluminum and sulfate. Those are my charges. And I have barium. Okay, so aluminum sulfate, 3 of these, 2 of these. I balance my charges out. 2 of those, 3 of those, plus barium. And we're going to produce barium sulfate and aluminum. Barium is a positive 2. Sulfate's here, so 1 of these and 1 of these. Here's barium sulfate plus aluminum. Letter B, magnesium and copper 1 nitrate. So magnesium by itself is just Mg. Copper 1 nitrate. Remember, the 1 means positive 1 charge, and nitrate is negative 1. So I got Mg plus copper 1 nitrate, and it will make magnesium nitrate and copper. The only thing that's different is magnesium ions positive 2. So positive 2 and nitrate. If I need 2 nitrates, don't forget to put it in parentheses. And we're just talking about copper metal. So those are the first two. Now I'll try to do C right below it here. Actually, I'll do C and D on a separate, or erase and do those over. So C, letter C, says sodium and calcium phosphide. Sodium is Na, calcium phosphide. Calcium's 2 positive, phosphide's 3 negative. So I got sodium plus calcium phosphide, 2. And that's going to make sodium phosphide and calcium. Sodium is positive 1. So sodium is positive 1 and phosphide is negative 3. It's Na3P plus calcium. And then letter D, phosphorus and sodium chloride. Sodium chloride, Na is positive, Cl is negative 1. So phosphorus plus sodium chloride will make sodium phosphide and chlorine. Sodium phosphide is this, and chlorine by itself is just Cl, but it's also one of our diatomics, so it's going to be Cl2. All right, so number 6 says, each of these follow a similar pattern. What's this pattern? And here's the pattern. The pattern is, I have a single element in a compound. There's replacement that occurs. The element replaces, and I get a new compound and a new element. So it's element compound makes element compound. How are the reactions in 5C and 5D different, and how are they similar? They're similar in the fact that they both have element compound, but here's what's different. Na replaces what's in front. P replaces what's in back of the compound, if you notice that. So what's different is what's replaced. So Na replaces Ca, and P replaces Cl. So that's how they're different, but they're similar in that they both have, they're both the same type of reaction, element compound, element compound. Number 8, complete the following reactions. So I look at number 8. Number 8 has NaCl plus Ag. So I look, now Ag is going to replace either the Na or the Cl. So I look on the periodic table. Ag is a metal, Na is a metal. Cl is a non-metal. So like replaces like. So Ag will replace Na. So Ag will go with the Cl, and Na will be by itself. Now I have to know charges. Silver is always positive 1, chloride is always negative 1. And then I got AgCl plus Na. B, Li plus Ca3 PO42. Li is a metal, which makes a positive charge, so it replaced the other positive charge. So like replaces like, so Li will go with the PO4, and Ca will be by itself. So I'll have Ca by itself, but now I got Li and PO4. Li, positive 1, PO4 is negative 3. So I need 3 of these to balance it out. It should be Li3, PO4. But positive replaces positive, negative replaces negative.
Okay, so compared to what you saw on the board in the example, please check yourself. Now, each of the reactions I wrote in question 5 follow a similar pattern. The same pattern is followed by the questions 3 and 4. Describe the pattern that you see. And it should be, hopefully, one element reacts with a compound to produce a new compound and element. Now, how are 5C and 5D different? 5C the positive charges replace each other, while in 5D the negative ions replace each other. How are they similar? Well, they still have the element and compound reacting. So let's complete the following reactions. We'll do that on the board now. Okay, information. Each of the equations that you looked at in the above section is called a single replacement reaction. Notice that in each of them, a single atom replaces an ion from another reactant. What happens in the following reactions? They are called double replacement reactions. Look closely. Compound, compound, make compound, 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 make compound, compound, etc., right? So what's the difference between a single replacement reactions and double replacement reactions? Well, single replacement reactions have an element involved, while double replacement are all compounds. So complete the following reactions by writing formulas for the missing compounds. Do it now.
All right, so these are going to be double replacement reactions. This is number 10. So I got this compound plus something will give us these two things. So I have Cu and NO3 here. So if I got Cu and NO3, which leaves me with Na and Cl to go here. So I write Na and Cl, find their charges. It's a 1-to-1 ratio, so my answer is just NaCl. Okay, I got Zn and I. So Zn and I leaves me with Al and SO4. Al and SO4. Al is positive 3. Sulfate's negative 2. I balance my charges. Al2, SO4, 3. That's a 3. Okay, so here, K2O plus MgBr, the Mg and the K switch places. So Mg goes with the O, and K goes with the Br. Find my charges. Positive 2, negative 2, positive 1, negative 1. MgO, KBr. Number 11, the reaction between calcium phosphate and sodium iodide. So calcium phosphate and sodium iodide. Calcium phosphate is Ca and PO4. And we're adding to that sodium and iodide, so Na and I. So I know my charges. 2 positive, 3 negative, positive 1, negative 1. So make this compound Ca3, PO4 2 plus NaI. And what's going to happen is the Na and the Ca are just going to trade places. The Na goes with the PO4, so I'm going to have Na and PO4, and added to that I'm going to have the Ca and the I. And the charges don't change, they're the same as they were initially. And so now I just balance my charges. Na3, PO4 plus Ca, I2. So that's your answer to number 11. Number 12, explain why when you mix the following reactants, no reaction occurs. And that's an interesting one. You got Na2SO4 plus NaCl. Remember in double replacement, the two front ones change. So if Na goes with this and Na goes with this, nothing's going to change. You're going to start with what you finish with. So nothing's going to happen.
11, name the two products in reaction between calcium phosphate and sodium iodide. Do it now. And 12, explain why when you mix the following reactants, no reaction occurs. Do it now. And now the other three types of reactions are combustion, synthesis, and decomposition. So another type is combustion. During combustion, a hydrocarbon reacts with oxygen. The products for complete combustion are always the same, water and carbon dioxide and energy. So here's an example of combustion of hydrocarbon. Hydrocarbon plus oxygen makes carbon dioxide and water. And those are the things that you'll always see. So water and carbon dioxide will be products, and oxygen will be a reactant. The other two types are synthesis and decomposition. During a synthesis reaction, several reactants combine to make a single product. During a decomposition, one reactant decomposes into two or more products. The following table shows some examples of these types of reactions. So you can see two reactants, one product. Two reactants, one product. One reactant, two products. One reactant, two products. So a synthesis is where you only have one product. And decomposition is where you only have one reactant. So let's categorize these different reactions. So we have one product, which would make this a synthesis. So S. This is going to be a hydrocarbon, oxygen, carbon dioxide, and water. So this is for sure a combustion. Okay, this is going to be a replacement reaction. We have a compound and an element. The F and the Cl trade places, and we have a compound and an element. Since there's an element involved, it is single replacement. Here we have another replacement reaction. A compound and an element makes a new compound and a new element. Again, since there's an element involved, it is a single replacement. Here we have a single reactant, which makes it a decomposition. And then the last one, we have product, or compound, 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 compound. So all compounds, which makes this a double replacement. And that's how you can differentiate between the two. Equation for the combustion of C3H6. Do it now.
All right, so these are going to be double replacement reactions. This is number 10. So I got this compound plus something will give us these two things. So I have Cu and NO3 here. So if I got Cu and NO3, which leaves me with Na and Cl to go here. So I write Na and Cl, find their charges. It's a 1-to-1 ratio, so my answer is just NaCl. Okay, I got Zn and I. So Zn and I leaves me with Al and SO4. Al and SO4. Al is positive 3. Sulfate's negative 2. I balance my charges. Al2, SO4, 3. That's a 3. Okay, so here, K2O plus MgBr. The Mg and the K switch places. So Mg goes with the O, and K goes with the Br. Find my charges. Positive 2, negative 2, positive 1, negative 1. MgO, KBr. Number 11, the reaction between calcium phosphate and sodium iodide. So calcium phosphate and sodium iodide. Calcium phosphate is Ca and PO4. And we're adding to that sodium and iodide, so Na and I. So know my charges. 2 positive, 3 negative, positive 1, negative 1. So make this compound Ca3, PO4 2 plus NaI. And what's going to happen is the Na and the Ca are just going to trade places. The Na goes to PO4, so I'm going to have Na and PO4, and added to that I'm going to have the Ca and the I. And the charges don't change, they're the same as they were initially. And so now I just balance my charges. Na3, PO4 plus Ca, I2. So that's your answer to number 11. Number 12, explain why when you mix the following reactants, no reaction occurs. And that's an interesting one. You got Na2SO4 plus NaCl. Remember in double replacement, the two front ones change. So if Na goes with this and Na goes with this, nothing's going to change. You're going to start with what you finish with. So nothing's going to happen.